Hello everyone. So this is the third numerical from tension member. So before solving this numerical, try to understand the question, what it is asked. The determine the net effective area, determine the net area for the angle section shown in figure 6.3. The angles are connected with 18 millimeter diameter bolts of grade 4.6. The steel is of grade 410. Okay, so just let us concentrate on the figure first. Here on this side there is an angle section ISA 175 into 10. This is 100, this is 75. Okay, and the thickness is 10. So this view is from the front side. You can see from the right side also. Okay, so you will see an angle section. So this is a 3D figure. Try to imagine that. Okay, and the bolt that is bolting on the two legs, so the spacing is given, that means from this edge the bolt center of the bolts are 40 millimeter, then it should be 60 obviously, so it is 75 millimeter total, so it is 30, it is 45. Okay, so then read this. So 18 millimeter diameter bolts at 55 millimeter pitch, that means the bolts will be at a pitch of at a spacing of 55 millimeter. So from if you select the first line of bolts here, then this bolt, the bolts on this leg will be at a spacing of 55 millimeter. Then from this bolt, other line of bolts will be 55 millimeter spacing. Okay, like this. So if you rotate this leg, okay, so it will be a plate. Okay, so if you rotate this leg, this outstanding leg, or not actually outstanding leg because it's connected by bolts, so if you rotate this leg, it will be a plates. Okay, so it is the first bolt, and with this bolt on this leg the bolts which will be at a spacing of 55 millimeter. Okay, then with this bolt there should be another bolt actually here. Okay, there should be another bolt on this leg. Okay, on this leg, so it should be at a spacing of 55 millimeter, and from this bolt to this bolt spacing should be 55 millimeter. So this is the figure. Okay, now in this type of case I have told you earlier that if the angle section are connected on both the legs, and if you want to rotate, then you should find the gauge distance or modified gauge distance, because if you when you are rotating this leg, so there will be some overlapping portion here. So you will not from this bolt to this bolt, the spacing will not be 60 plus 45, because if you rotate like this, so there will be some this part will go inside this line, no? So that's why the modified gauge distance or modified spacing from this bolt to this bolt will be like this. G1 G star is equal to G1 plus G2 minus T. That means this is G1, this is G2 minus T is the thickness. Okay, so that's why from this bolt to this bolt, because this is the bolt on the vertical leg and this is the bolt on the horizontal leg. So the spacing, vertical spacing between these two bolts will be 60 plus 45 minus 10. That's why it is 95 millimeter. Okay, now if it is equivalent to a plate, now as we have solved the first numerical of tension member, we have chosen different paths for finding the net section. So here also we will find, we will assume some path, and we will find the net section along those paths. Okay, so let us assume that along A, B, C there will be a net section. Okay, the section may crack, or there may be rupture. Okay, and secondly we may assume that along A, B, D, E there may be some crack. Okay, and thirdly, if you want to assume, you can assume that from this point to and this point to, like this point and this point. Okay, if you can name here, so it may be F G D E. Okay, so like this you can assume different paths and you can find the net area along different paths. Okay, so let us come to this figure. So net area along path ABC, A, B and C is equal to, so along path ABC there is total length is equal to how much? So from this point, this bolt to this bolt, it is 95 as we have solved this. So 95. Okay, then 95, and this is 30 and this is 40. So you can find the total breadth. That means uh, 40 plus 95 plus 30. How much? 40 plus 95 plus 30, that means 165. Okay, so B is equal to, so total is 165 minus NDH. So because in this path there is only one bolt, that's why N into DH. So DH is the hole diameter. So there is a total length along this path. So you have to multiply the thickness of this plate. Okay, so because this is not a simply a plane, it is a plate, na? Because you have rotated this leg uh, to make it a plate. Okay, you have to imagine that it will be a plate if you rotate like this. Okay, so it is a plate, so that's why it will have a thickness. So B minus NDH into T, 165 minus number of bolts is 1 and DH is 20, so that is this. Okay, I hope you understood. Then net area along path ABDE. So ABDE. Okay, so in this path there is two bolts. So and the line of path has changed only in one time. So as we know, so in this case, when the path changes or line of path changes, then we have to add some staggered distance. Okay, so B minus N into DH plus N dash into P square by 4G bracket complete and then into T. Okay, so here N number of bolt is 2 and number of path change is equal to 1, N dash is 1, P is equal to 55, this 55. So and G is equal to how much? So from this bolt to this bolt, this change of path is occurring here. So from this bolt to this bolt, the spacing is 95. So that's why it is G95. So you can find this answer AN2. So third case, you can find uh, area from this point to this bolt, and from this to this, and like this. So it will be same uh, with ABDE because the uh, alignment is same in both the cases. So you don't need to find out that. Okay, so minimum of these two path will give you the net section. So the minimum governs the failure, that's why the minimum should be chosen. So an effective net area is equal to 1329.60. So I hope you understood. Okay, so now the next figure is this. So in this figure 125 into 75 into 10 millimeter bolts are given, sorry, angle are given. So there are two bolts line on here and here, and on there is a also bolt. Okay, we don't know the number of bolts here from this figure. Okay, we should uh, there should be some uh, other picture. Okay, or because this is a front view, so you have to assume that there is a infinite length, or maybe certain 2 or 3 meter length maybe. Okay, so From that we can draw this figure. So this is a cut section. Okay, so it is just you have to notice something here. That is, first is this is 35, this is 50, this is 40. Okay, this is 45, this is 30. And thickness is 10. Then 18 millimeter diameter bolts for vertical leg, staggered at a pitch of 50 millimeter. So the on the vertical leg there are two line of bolts, this bolt and this bolt. So spacing of this bolt, if you put a bolt here and if you put next bolt here, then the spacing between the two bolts should be 50 millimeters. So like this. So here is one bolt. Then if you place second bolt, the spacing should be 50 millimeter. So it is mentioned here 50 millimeter. Okay, like from this bolt to this bolt, the spacing should be 50 millimeter. Okay, and so on. Okay, now for horizontal leg at a pitch of 100 millimeter. So from this is a first bolt on the horizontal leg. So from this bolt to second bolt it should be 100 millimeter, and so on. Okay, I hope this picture is clear now. Now here here also we have to rotate this leg to assume it as a plate. Okay, so if you rotate this leg, then from this bolt line to this bolt line you should find the gauge distance or modified distance. So so from this bolt to this bolt, the spacing or the distance will be simply 40 plus 45 minus t. That means 40 plus 45 means 85. 85 minus 10, that means 75. So like this. Okay, so that is the uh, modified distance. Now you can find the total distance from this point to this point, I hope. Okay, so here also after rotating this leg, uh, you have you can imagine that it is a plate. Now the numerical on plate you have done on the first numerical. Okay, so from the first numerical you can understand that you have to assume some paths. So you can choose a b c d path, you can choose a b e f. Okay, and third you can choose a b e g h. Okay, so I will not solve this part. I will just dictate it here. So along this path a b c there will be two balls and there will be no change of path. So you can understand what should be done here. On the second path a b e f there will be one change of path. So it will be so the end dash should be one here. Okay, then for the third case along a b e g h there will be two change of path here and here. Okay, so uh, here also this end dash should be two here for the uh, third path along a b e g h. So one for this path and one for this path. Okay, so I hope you can solve this numerical then. Okay, and one thing I want to mention here. So what will be this distance from this point to this point? So as we know, this is 35, this is 50. So 35 plus 50, and from 50 to this point it is 75 solved, and then 30 plus 30, so it should be 190. So I hope you can solve. From this three part, the lesser one will be selected as the effective net area because lesser area will be governing the failure. So I hope you can understand. If you have any query you can discuss in our Google Classroom or WhatsApp, or you can directly contact me. Thank you.